All right, so today we're approaching the end of the calculus year, getting ready for the AP test. So this is a good review. This is a quiz I give often, fill in the blank. And if you pause it, you can answer the first 10 here. I'm going to go awfully quick because really at this point, we should be able to do these quickly. So the first one, derivative of sine is simply cosine. Derivative of tangent is secant squared. Derivative of secant is secant tangent. And make sure you include the argument, the x. I'll work the other way. Derivative of cosecant is negative cosecant x cotangent x times cotangent x. Derivative of cotangent x is negative cosecant x squared. And finally, the derivative of cosine is negative sine. And the reason on this quiz why I did this is I wanted you to catch that all the derivatives of trig that start with a C are negative. All right. So again, you got to just put these in your memory bank. We have to do this. We have to know them frontward and backwards so we can use them for integration. Product rule is simply if you have f times g, what is derivative? Well, the derivative is f prime g plus g prime f. And the quotient rule, if you have f over g, it's just f prime g minus g prime f all over g squared. The derivative of a constant is 0. The derivative of 6 is 0. The derivative of 8 is 0. The derivative of pi is 0. On number 10, it might help you could picture the graph. And you can see that they're both coming up. I don't want this stated as undefined. I want it stated that this goes to positive infinity. And again, you can check it on a table, go on each side, and you can see that they're both positive numbers going to the same part, leading up to positive infinity. Either way, again, it's a pretty straightforward answer for us. All right, so number 10 is positive infinity. The next problem was this one. Solve the following. No calculus for the integrations, and then just take the integral of 1/3 x squared. And again, this is kind of set up to, again, to give you practice longhand. Pause the video, try it. The big thing is that I see as I start this, the 1/3 is a setup. If I integrate x squared, I get x cubed over 3, and I'm going to evaluate that from -1 to 3. It's not, the 1/3 doesn't disappear, it becomes 1/9. So I get 1/9 times x cubed from -1 to 3 if I bring it out, because it's a coefficient. And then I get 1/9 times 27 minus a minus 1. So I get 28/9 is the answer for this problem. All right, I have another page on this. We'll go to that. You see that there are two derivatives here. It says get the first derivative for the problem in 12 and 13. So I'm looking for g prime and h prime. This is a combination of the product rule, f times g, and g is a product rule. So we're going to use f prime g plus g prime f. So the notation is g prime of x equals derivative of 3x to the 4th is 12x cubed times tangent of 2x squared plus, now I'm just going to write this out. F doesn't change, so it's 3x to the 4th times the derivative of tangent is secant squared. So I'm just going to write secant squared of the argument 2x squared. And now it's the train rule portion. You have to take the derivative of the inside argument. The derivative of 2x squared is 4x. If you reduce, whoops, a little bigger, big eraser. If you reduce this, all right, if you reduce this, you're going to get g prime of x equals 12x cubed times tangent of 2x squared plus 12x to the 5th secant squared 2x squared. 13 is, again, a chain rule. Again, the thing I see before I write h prime is I see this as this. The radical turns into an exponent of 1/4. So I just bring the 1/4 down for h prime of x times x cubed plus 2x minus 4. 1/4 minus 1, negative 3/4, then times the derivative of the inside, 3x squared plus 2. And I'm not going to simplify that any more than that. Finally, the last two on this, for good review purposes, are these two limits. Value the limit if it exists, no calculator, and show your steps. Again, putting these in the calculator is not the challenge. We want to be ready for the AP. Don't calculator section. Pause me, give this a shot. On the first one, you got to catch that there's a radical, so I'm going to multiply the top and bottom by the conjugate. Let's see what happens. Because right now, if I plug 0 in, the bottom is 0. So I don't want to do that. Top and bottom by the conjugate. I get limit as x approaches 0 of 1 minus x squared over x times. And again, I don't want to multiply this out. We're trying to get the x to cancel. And look what happens. The 1s cancel, and I get a positive when I distribute. So I can cancel an x, and I get the limit as x goes to 0 of x over 1 plus. And if I plug 0 in here, I get 0. So thus the limit of that is 0. Last one. If you factor it, again, you plug 2 into it, it doesn't work. Because x minus 2 is 0 on the bottom. But when you do this, you simply factor the binomial. These cancel. 2 plus 3, you get the limit of this is 5. Showing this stuff. Keep practicing some real easy problems, getting us prepared for the AP.